Hello everybody, my name is Luis Gonzalez and I'm going to be presenting my design for assembly project on an Olympic barbell. Before I get to explaining all the different components that make up the entire assembly, I'm going to be explaining why I chose this product as my project. So as you all know, Olympic barbells are used for various reasons, whether it would be at home or at the gym, but the purpose of it is to maintain fitness and while also performing in weight training, bodybuilding, and weightlifting, and other kinds of workouts that could be done. But barbells do tend to hold a lot of weight. And compared to standard barbells, the Olympic barbell should be more durable and they should be able to sustain plenty of weight without having to worry about any malfunction happening while pretty much operating the barbell. And unfortunately for me, I was here at home working out and I actually experienced the barbell coming apart and all the plates shifting towards the middle where you hold it at, and I decided to do the project on this, seeing how I can improve the assembly of it, and while also tackling down the design for assembly, which will help reduce the number of parts needed to make up the entire assembly. So here going into all the parts of the original model and how it functions, we can see that these are some of the parts that make up the entire assembly, which here we can see the hex bolt washer that goes on the hex bolt and another washer that goes on top of this other washer, and we see a sleeve, a collar, and as I have the list here, there's a fastener, gaskets, cast irons, and the shaft, which we will get to right now. And I have only showed one of each because on the other side is pretty much the same. It's just I'm doing one side so it can be a little bit easier to understand. And here the other parts that make up the entire assembly, as I said, is the fastener here that goes in on top of the shaft here, with 3 cast irons that go on top of the shaft under the sleeve, and these 2 gaskets that protect the gaskets from making contact with the collar. And here is the entire design assembly. As you can see, like I explained, the collar screws on to the sleeve here with the fastener going in here to not allow any contact with the cast irons, and these gaskets protect it from come crashing down on the collar inside here. And on this other side we see the washers with the hex bolt attached here. Once the shaft goes into the sleeve, we can see that the bolt attaches to the shaft itself, causing it to pretty much stay in place. And the reason why I chose this project, like I said earlier, was because the collar, inside the collar, we have some threads that screw onto the sleeve here, and I guess over time the threads were coming loose and the threads fell out, and the collar here slid off to the left and caused all the plates on the sleeve to fall out and made me pretty much drop everything right there where I was at. So in order to improve the assembly of the sleeve, I decided to make a manufacturing plan. So using the manufacturing program in the software in Autodesk, the stainless steel stock will undergo several phases using machine tools such as turning, drilling, facing, profile, roughing, grooving, and profile finishing. Once the sleeve has been machined down to its proper dimensions, a NC program was created to generate a G-code for the proper operations, which we will see here in the next few slides. But first, I want to show you guys a video I recorded here just a little bit ago where the sleeve is undergoing the machining process. So first it starts with turning of the stock. The stock first undergoes facing to get a clean cut at the end of the stock. Then we can see where it undergoes profile roughing, which is what it's doing right now, with a few passes to trim the stock down to an offset of 1 millimeter of the sleeve. After it has roughed down the stock to its proper dimensions of the sleeve, I use the profile finishing tool to cut the final turn of the stock. Once the stock is ready with its proper dimensions, the grooving tool was used to part the sleeve from the unwanted stock. After the sleeve has undergone all the turning tools, I use the drill on horizontal position to drill the holes for the shaft on one end and the hex bolt on the other end. And I will show the video here one more time. This is all the profile roughing right here, and then that's the finishing. That's the grooving, and then the milling part comes in to drill the holes on each side of the sleeve. So once I got all that prepared, I obtained the G-code from the NC program, which was created and processed. So now getting into the design for assembly section, this whole project is based off of this DFA to minimize part count, to incorporate multiple functions into single parts, to make parts easy to identify, and mainly to reduce the parts that it takes to assemble the product. And by doing all of this, it allows to increase cost savings because it allows for less time to be produced and less parts to use to be produced. And here we can see how the original part on one side has 12 parts, and if we add it together, it'll come up to 23 parts because of all these components that it has here in the original assembly. And once the modified sleeve has been done in the machine, we can reduce the count from 23 to a total of 7 parts, which is just the sleeve, the washer, and the hex bolt, along with the shaft. So here I'll be showing the redesign of the parts based off of the design for assembly. And here are each individual parts, which is the sleeve, the washer, hex bolt, and the shaft. So as we can see here, we can see how the shaft was modified to have threads on the end to be able to screw in the sleeve, and while also securing both of them with this hex bolt, which will go here just like in the original assembly. No parts were modified as far as size and thickness. Everything stayed the same. All I wanted to do was just reduce the number of parts and make it a little bit more secure so the sleeve won't come apart. So this whole Olympic barbell assembly, I showed how it malfunctioned on me and how I used the design for assembly to improve the design and how it eliminated the risk of any future failures or malfunctions. And like I said, no changes to the dimensions were done. And in regards to that, the purpose of the Olympic barbell was not compromised. Since everything stayed the same, we just reduced the number of parts inside the assembly. And like I said, after implementing design for assembly, the number of parts to assemble reduces, and which causes less cost and less time to make. So that increases cost savings. So now I'll be demonstrating the entire assembly in Fusion 360. So I'm going to be demonstrating here the original assembly of the Olympic barbell, and we'll get to the modified part here in just a second. So what I want to show you guys is how this whole assembly works. So we got the shaft here, which has a 7/16 hole with threads, so a bolt it goes in there to be attached into the sleeve and pretty much keep the whole assembly in place. So if we start here with the collar, you can see that it has threads, which is where the whole problem started with the sleeve coming off of the collar, causing this collar to just slide off and all the plates coming this way. And if we go here into the individual parts, you can see the fastener that comes in here and stops all these components that we're about to see here shifting towards the left. And this here's your fastener, and you got two gaskets that protect the components inside here from these cast irons that go underneath the sleeve. And on top of these cast irons, we have the sleeve, which is screwed on to this collar right here. And you see here, you can see that the shaft comes into the sleeve, and we attach a washer with a bolt and secures the whole thing here. And that's what pretty much makes up the entire assembly. So if I go and open all these up here, we can see the entire assembly all together. I have this in color so we can easily differentiate between each component. But over here is the actual physical material, which is stainless steel. And for the modified part, I have switched screens here. We can see here, it's better if we look at it as an individual part. You can see the sleeve here by itself. So, as explained in the modified part section, I added some threads here at the end where it'll allow the shaft to go in from this side. And it will add more security here with these threads, of this thread in here. And once it comes in here, we can go ahead and attach a washer and a bolt with it, and pretty much eliminating all these parts that are underneath the sleeve. So that makes up for the entire project. That's I showed the original assembly versus the modified assembly, where it allows the Olympic barbell to secure more weight and avoid any future risks. Thank you.